Welcome. Let's work through section 5.1, beginning chapter 5. This is going to be a chapter where we're getting into more of the trig functions. So section 5.1, just a nice introduction with angles and degree measures. You'll learn a few new things, I'm sure. Angles. We are going to talk about angles getting placed on the coordinate plane. And an angle is considered to be in standard position when its vertex is located at the origin. And the origin, we're talking about that location 0, 0. And one of the rays, the initial side, is on the positive x-axis. So far, if you look at your coordinate plane, we have the vertex sitting at 0, 0. And we have an initial ray at the positive side of the x-axis. The other ray, which will be called the terminal, and what does terminal mean? Well, think of the word ending. The ending side, or the terminal side, is where the angle ends. So if I had an angle maybe of 135 degrees, in standard position here, I would have its initial ray on the x-axis, and I would have my vertex located at 0, 0, and this would be considered my terminal ray, or terminal side. That is what's known as standard position. So just take a moment here and draw in your standard position angles. 320 degrees. Now, not very often have you worked with angles greater than probably 180. Let's just kind of review that. If I'm in standard position, this would be 0 degrees. Up on top would be 90 degrees. Over to the left, 180 degrees, 270 degrees, and then wrapping back around and finishing at 360 degrees. So one full revolution will be 360 degrees, just like we know the degrees of a circle. If I want 320 degrees, I am going to start at the initial side and wrap around until I finish a little bit beyond 270, and that would be my angle. So it starts at the positive x-axis, wraps around, and finishes down in quadrant 4. Negative angles. Not very often have we worked with negative angles. Positive angles go counterclockwise. Negative angles go clockwise. So I'm going to start at 0 degrees, and I'm going to go backwards 110 degrees. So this would be negative 110 degrees, backing up that way. 990 degrees. Wow, 990 degrees. Well, I know 360 degrees would be 1 revolution. Another 360 degrees would be 2 revolutions. Together, this adds up to 720 degrees. I don't think another full 360 will go in there, so I'm going to take 990 and subtract 720 from it, and that will leave me 170 degrees. So I'm going to wrap once, there's 360. Wrap twice, that's 720, and now I am going to go an additional 170 degrees, which would be almost back to the negative x-axis there, and that would be my angle of 990 degrees. Wraps around fully twice, and then not quite halfway around the next go around. Coterminal angles, another term that we need to get familiar with. Coterminal angles are angles in blank position with the same blank side. These are angles that start in the standard position, and they have the same terminal side, meaning they finish at the same spot. They coexist. One way to find a coterminal angle is to add or subtract 360 degrees or multiples thereof 360 degrees. For example, the angle 65 degrees. If we just plot out 65 degrees, you know, maybe it's somewhere right about in there. I have a 65 degree angle. Its reference or its coterminal angles would be angles that finish at the same spot. Well, I could take and wrap around once and then come and stop, right? So I could go 65 degrees plus 360 degrees will equal an angle of 425 degrees. Next, I could find an angle by subtracting 65 degrees minus 360 degrees. Let's just find what that difference is, and we know this answer is going to be negative. So borrowing, I would have 5 and a 2 and a 1, 295 degrees, but 65 degrees minus 360 will be a negative 295 degrees. On this one, it would look like I'm starting at the positive x-axis, and I'm going to go around. There's 180 degrees, there's 270 degrees, and I'll finish it at negative 295 degrees. And notice they all have that same terminal ray as their finishing point. That's what's meant to be a coterminal angle. There's ways to write many coterminal angles, and that's where I just go 360 degrees times some integer k, where k is like 1, 2, 3, 4, dot, dot, dot. I could do 360 degrees or 365 degrees minus 360 k as well. Really, only one of these is necessary because if it's an integer, my k could have been any of those as well. And also k could have been a 0, which would give us just 65 degrees. Coterminal angles, 410, one similar to it. So 410, that wraps around once, that's 360. And then I'd have to go another 50 degrees, wouldn't I? And that would be my terminal side of my angle. If I added 360 to it, I'd be at 770 degrees. That would be a coterminal angle. If I subtracted 360, 410 minus 360 is 50 degrees. If I wanted to get a negative angle, which I think you have to do when you're in your homework, I would subtract another 360 so that I get into a negative 310 degrees. And then notice how this will finish back around at that point, negative 310. Or if I wanted to write many coterminal angles, I could do 360 degrees times some value k, meaning I could have 2 times 360, 3 times 360, and continue to add on all these revolutions around it. 360 k, I could do subtraction as well. All right, so we've had standard position, we've had coterminal angles. Now let's talk about reference angles. This chart should be somewhat helpful. I'm trying to show you the different scenarios in the the 4 different quadrants. And if I have an angle in standard position, then there is some angle that stops in angle 1. You'll notice that this is an alpha symbol. It's a Greek letter, often used to represent an angle measure. So we're just assigning it the measure of alpha. In a reference angle, in quadrant 1, the reference angle is the same as the actual angle. For other reference angles start out as an angle in standard position, which means that they have their positive x-axis as their initial ray. And then these reference angles are always expressed as a positive acute angle. So there's 2 things about them. They're positive and they're acute. And the other thing is they are always from the x-axis. Now that might be the positive or the negative side of the x-axis. Quadrant 1, I put a note. Quadrant 1 is its own reference angle. Quadrant 2, the reference angle, here's my angle alpha. The reference angle is going to be represented by this portion right in here, where I'm trying to state it as an acute angle, and I want to make sure I state it as a positive amount. The angle always has one of its sides bordering on the x-axis. So, example here, 135 degrees. It is an angle that finishes in quadrant 2, and it has a reference angle then right here of this amount. If I had to calculate how much that was, I could take 180 degrees and subtract 135 degrees, get 45 degrees. Negative 105, now this one's going to be a little bit different. Negative 105 just barely past negative 90 degrees, finishes right down here. Its reference angle is going to be represented by this acute angle. So notice it's acute, and it's against the x-axis. The way I find that amount, I'm going to take 180 and subtract 105, and it will tell me that this amount is 75 degrees. So this one has a 75 degree reference angle, and that first one had a 45 degree reference angle. It's just another way of expressing angles according to a positive acute. It has to do with our trig functions, and it'll make more sense once we get more deeply involved with the trig values. Reference angles, 325 degrees. 325 degrees finishes beyond, this is 270, so it finishes beyond there, picking it up right there. I'm looking for an acute angle that rests against the x-axis. That's going to be my reference angle area right here. And the way to calculate that, I'm going to take 360 minus the 325, and that's going to leave me with a 35 degree reference angle. Negative 325 finishes me up in quadrant 1. And the way to calculate that one, once again, 360 degrees minus 325 degrees. It has a reference angle of 35 degrees. Notice they each have the same identical reference angle. Their trig functions are going to be very similar, maybe just off by a positive or a negative. 240 degrees stops before I get to 270. We know 270 degrees down here. Where is the reference angle? It is the acute angle that rests against the x-axis, so right in there. How am I going to calculate that? Well, I know this was 240 degrees, wasn't it? This is 180 degrees. What I notice is 240 degrees is beyond 180 degrees by 60 degrees. So I'm going to take 240, subtract 180, and it equals 60 degrees. By drawing a picture, you can really help yourself figure these out. All right, then we get into degrees, minutes, and seconds. And I think I'm going to hold off on that. We can cover that in class, beginning of class when we get together tomorrow. So thanks for listening.